Welcome to the presentation on studying chemistry at A-level at Briggs Sixth Form. Here we will take you through the details regarding the course, teaching, entry requirements, why you might want to study chemistry, and the avenues that studying chemistry opens up for your career pathway.
Like most A-level courses, chemistry is taught by two specialist teachers, myself, Andrew Williams, and Dr. Simon Turner, who you've already met. We're both highly experienced A-level teachers and examiners with over 50 years of successful delivery at A-level standard between us. We're passionate about our subject and we expect our students to share in our enthusiasm. In addition, we're particularly proud of both our excellent examination results and the success of our students, all of whom this year have gone on to achieve places at their chosen university, many of them engaged in science degrees.
To study A-level chemistry, it is vital that you achieved at least a grade 6 level at GCSE level in chemistry. This can be done at triple or combined science. During both years, students were required to have competent mathematical ability. As such, it is required that students have also achieved a grade 5 for GCSE in mathematics. Chemistry A-level is high in content and knowledge-based learning. Students must enter the course with a real interest and desire to learn and be willing to rise to the challenges they will set during the course.
So, what can you expect by choosing chemistry as an A-level subject? Firstly, chemistry is an absolutely fascinating subject in its own right for anyone who is interested in learning how the world works. It's also a central science to support other key science subjects such as biology and physics. At Briggs Sixth Form, you can rest assured of receiving an excellent standard of teaching and the use of superb resources and facilities. You can also expect this to be delivered by teachers who care. Within this atmosphere of ambition and high expectation, every student is encouraged to give of their best. Our smaller group sizes mean that we can provide lots of individual attention and a personalised approach to learning, which caters for the needs of all our students.
Chemistry will be for you if you have an innate interest and want to develop a knowledge about how materials and systems work and interact. Throughout the course, students are provided with opportunities to cultivate a thirst for scientific knowledge and develop their practical skills, analytical approaches to problem solving, which equip them for life in a modern society. Chemistry offers opportunities to develop skill sets through being analytical, independent and research-based, being communicative and experimental. As such, this opens up many avenues for students to take post A-level, providing many different career opportunities or pathways to follow.
As you can see, A-level chemistry follows a 2-year linear course. What this means in practice is the students take all of their examinations at the end of the second year of study, and we use the intervening time to prepare them well for this, as well as developing along the way a highly useful and relevant set of key practical skills and abilities. In terms of time commitment, to succeed at the highest level does require a considerable investment in time and effort. We therefore expect students to put in at least as much time doing personal study outside lessons as they spend within lessons, ideally a minimum of 4 hours per week. This takes the form of completing assignments, reading around the subject, performing research, and writing up practical work.
For A-level chemistry, there are 6 units covered. Module 1 is development of practical skills in chemistry. This is comprised of 12 practical-based tasks which develop abilities to use practical techniques to investigate and solve problems, use apparatus appropriately and implement procedures skillfully and safely, as well as learning to record and present results in a scientific way. Students will also be taught how to conduct their own research of their work. For Module 2, which is Foundations in Chemistry, this covers the building blocks of all of the modules, such as atoms, structure and bonding, molar calculations, equipping students with the basic skills for the rest of the course. In Module 3, the pupils will study the periodic table and energy. This module covers the important ideas for inorganic and physical chemistry, such as periodic trends and concepts such as energetics, rates and equilibria. For Module 4, this is core organic chemistry, which introduces formulae, structures and basic mechanisms used in carbon-based chemistry. During Year 13, The modules involve further development and extension of Year 12 modules, such as quantitative studies of equilibria, rates and energy, study of transition metals as well. In inorganic chemistry, students develop more complex mechanistic approaches, learn about organic synthesis, and use analytical techniques to identify structures.
Assessment at A-level has changed significantly over the past few years. There are no longer separate module tests or AS level examinations at the end of Year 12, and instead the full A-level content is assessed through a series of terminal examinations at the end of Year 13. In addition, experimental work is included in the assessment framework as a series of required practicals, through which students must demonstrate a high level of competence in a wide range of investigative skills. Successful completion of these leads to them receiving an additional endorsement qualification alongside their actual A-level grade.
At the end of the second year, the students will write 3 exams, 2 of which have a 37% weighting and are 2 hours 15 minutes in length. They will then have a synoptic unified chemistry paper, which is 1 hour 30 minutes, carrying a 26% weighting. Students also receive a practical endorsement at the end of 2 years, based around the 12 practical tasks they complete during their course. For studying a science-based degree, it is a prerequisite that students have achieved this endorsement to start their course at university.
A-level teaching and learning is very different than that experienced at GCSE. For a start, A-level students are considered to be young adults in their own right, and they're treated as such, with the associated independence and status this brings. Students are also expected to take on a much greater responsibility for directing their own learning, and within the supportive atmosphere we provide, and in which they can mature and develop the knowledge and skills they will need to succeed at the highest level. In terms of the style of teaching and lesson delivery, this is also very different. Having smaller group sizes enables us to focus on individual learning approaches, including small group seminars and tutorials, alongside whole class discussions and research activities. Of course, investigative science lies at the heart of all that we do as chemists, and we always find time to deliver a substantial element of practical work within lessons.
Throughout the whole chemistry course, students will constantly be developing a variety of skills that can be used and applied outside of their education and in their future careers. As such, a chemistry A-level course provides a firm foundation in skill development for pupils for the future. Students will learn to be logical thinkers and develop better problem-solving skills, the ability to learn independently and carry out research to plan or find out key information on subject matter. They will enhance practical skills, developing more investigative approaches to tasks coupled with strong analytical and ICT skills to identify links, infer on results, and present their ideas appropriately.
Chemistry is a highly valued subject at A-level, not only for those wishing to follow a related scientific career, but for those wanting to prove that they have the academic prowess and rigour to succeed in many other areas. Besides complementing all of the scientific and technological pathways, chemistry opens doors in any career where skills of analysis, logical thinking, problem solving, and real-life applications of knowledge are required. The financial rewards can be considerable. And who knows, one day you could even follow a higher calling and become a chemistry teacher yourself.
I hope you enjoyed listening about what chemistry at A-level has to offer. And if you feel you have any questions or simply want to find out a little bit more about studying chemistry at A-level, please don't hesitate to contact us at Briggs Sixth Form. Thank you for listening.